Hi everyone, so we're going to talk about number 13 from the notes with a rational function. The problem says identify the points of discontinuity, holes, vertical asymptotes, x-intercepts, horizontal asymptotes in the domain of each, then sketch the graph. Okay. When it comes to sketching the graph, we'll use technology to approximate here what it looks like, but the more important points are our points of discontinuity and our asymptotes. Okay. So first thing we want to do, we're actually going to work backwards on this. We're going to start with the domain because that kind of leads us to where we need to be for points of discontinuity, holes, and vertical asymptotes. Okay, so the idea here is that when we do start with our domain, we can always assume, we can always start with assuming that our domain is going to be all real numbers. Okay, we can always assume that unless there's something glaringly obvious, we can assume that our domain is going to be all real numbers. Okay, and we just kind of chisel away from there based on what we see with the problem. Okay, so the way we kind of chisel away at determining what's not in our domain is we look at the denominator of our function. So our function is f of x equals x squared minus 16 divided by negative 3x squared plus 12x. So right here, remember the one number we cannot divide by is 0. So we're going to set our denominator equal to 0, so negative 3x squared plus 12x equals 0. And we're going to solve for x here. First thing we're going to do is we're going to factor out our common factor, which is negative 3x. And then what we're left with is x minus 4. Once we have that GCF, that greatest common factor, taken out, we're going to take our two factors right here and right there. We're going to set them equal to 0 and determine where our points of discontinuity are. So if negative 3x equals 0, x minus 4 equals 0. And then we solve these. Negative 3 times a number equals 0. That means that mystery number has to be 0. And then if we add 4 to both sides here, we get x equals 4. Okay? So this means that our domain is now all real numbers except x cannot be equal to 0 and x cannot be equal to 4. Okay, so that's the first part we can answer. Without even graphing it, without even looking at the graph, we know right away that that's going to be our domain. So anywhere else besides 0 and 4, that's what's going to be on this graph. Okay, now obviously we know that our graph is going to come out undefined at both 0 and 4, but what is there? Is it an asymptote, or is it a hole, or is it a jump? Okay, here's how we determine that. Okay, so for instance, if we plug in, or if we look at our function here, so we have x squared, so f of x is equal to x squared minus 16 divided by negative 3x squared plus 12x. Let's go ahead and factor both numerator and denominator here, okay? So the numerator is x squared minus 16. Both of them are perfect squares. It's the difference of squares. That means we can look at it as x plus 4 times x minus 4, okay? And then we know the factorization for the denominator, taking out a common factor of negative 3x. So we are left with negative 3x times x minus 4. Now, we can cancel out any algebraic terms and parentheses that they have in the same in both numerator and denominator. That means we can cancel out an x minus 4. When we do that, okay, that means that whatever we cancel out, that means that there's going to be a hole in the graph. Okay, so that means that x equals 4. Whenever we cancel out a factor, that means that we can assume that there is a hole in our graph at x equals 4. Okay, so that's the type of discontinuity we're going to have at x equals 4. When we're left with here, if we look at the function here, after we cancel it out, it looks like this, x plus 4 over negative 3x. Okay, so then that means at x equals 0, because we have nothing else to cancel out, that means that there's an asymptote at x equals 0. Okay, now what that means is when we talk about a hole at x equals 4, that means it's a point. Okay, so a point there, wherever x is equal to 4, but an asymptote is a line. So we're going to put in a vertical line at x equals 4, or I'm sorry, x equals 0. Okay, so there's my asymptote at x equals 0, because x equals any number is a vertical line. Okay, so I'm going to keep going here. I'm going to erase everything really quick here. And we're going to keep going with our figuring out what this graph looks like. Okay. All right, so now we want to figure out what our x-intercepts are. Okay, so whoops. So we talk about x-intercepts, that's where the function is equal to 0. Okay, so in this case, we want to figure out where the function is equal to 0. Now, the nice thing about that is we can assume that when we talk about the function being 0, we're talking more so about this right here, the numerator. Okay, here's what I mean by that. We said set the whole thing equal to 0, x squared minus 16 over negative 3x squared plus 12x. Okay, now if we wanted to, we could go ahead and we could eliminate, or not eliminate, but we could multiply both sides by our denominator. Remember, there are restrictions on that, so we have to be careful of that. But in this case, if we look at just the numerator here, so we get 0 equals x squared minus 16. We know that that's going to be difference of squares. So x minus 4, or sorry, x plus 4, x minus 4. Now one of these we already solved for. We already know that x cannot be equal to 4. Okay, so that means we're going to have to get rid of this right here because we know that that's going to be the one factor we can't deal with. But if we solve this equation, we subtract 4 from both sides, we say that we get x is equal to negative 4. Okay, and because we set it equal to 0, we know that one of our x-intercepts has to be negative 4, 0. Okay, so we know we're going to have an x-intercept right here with our graph at negative 4, 0. Okay, so now, last thing we have to answer is we have to answer what is our horizontal asymptote. Okay, so another asymptote that we have to answer is, do we have a horizontal asymptote? And if we go back to our original function, so f of x equals x squared minus 16 divided by negative 3x squared plus 12x. What we see here is when we think about horizontal asymptotes, or any rational function really, we want to think about what does this function look like when we have really big numbers. So basically, as x approaches negative infinity or positive infinity. Okay, so when we approach a really large number, how we want to look at this is we want to take a look at the coefficients of our largest degree. Okay, so the coefficient on the numerator x squared is 1x squared, and the coefficient on the denominator x squared is negative 3. This tells me that because I'm looking at 1 divided by negative 3, this tells me that there's a horizontal asymptote at f of x, or y, equals negative 1/3. Okay, so there's going to be a horizontal line at negative 1/3. Okay, so I'm going to draw in, not going to be pretty, but there's my horizontal asymptote right there. Okay, now, using technology, we're going to go ahead and we're going to sketch our graph. We know that there's going to be no y-intercepts. So on your calculators, you should be able to plug in this function here. The way I would caution you guys to do this if you're putting it in the calculator is just make sure you put parentheses both numerator and denominator here. And what you should see is, you should see this. You should see a curve that looks kind of like this. I'm going to put it in green here. Goes through that point, goes up like this, and then it comes back around like that. Okay? Now it's not perfect, but what we should notice is that, remember, we have a point, we have a hole at x equals 4. So I want to find that value here. So in case I need to draw a little bit better here. So what we're going to do is we're going to erase all my work again so I have some more room to work with here. And we're going to find out exactly what value that's going to be. Okay, and why there's going to be a hole in the graph there. So if we do f of -4, or I'm sorry, +4, here's what happens. So 4 squared gives me 16, divided by -3 times 4 squared, that's -48, plus +48. When we simplify this, we get 0 over 0. Okay, that's a problem for two reasons. One, technically we can't divide by 0, and 0 divided by 0 is not a number. Okay, so, but we can kind of, I'm not going to say cheat, but we can kind of assume something about this number here. We do know that the leading coefficient on the numerator is positive. Leading coefficient on the numerator or denominator is negative. So we can technically assume that this is a positive 0 and a negative 0. So a positive divided by a negative, and a number divided by itself is technically 1. So that means that the point 4, -1 is a hole in their graph. Okay, so I'm going to redraw this to show you guys. Should have probably done the hole first, but that's okay. So vertical asymptote gets to stay, and then the horizontal asymptote as well gets to stay. So now we get a graph, remember, a hole at 4, -1. So then if I keep following this, here's our hole right there, and it goes through forever that way. Okay. All right, guys. So that's how you find all the parts right here. Let me know if you have any questions on our HyperDoc, and I will see you on Wednesday.